right, next section in your notes. We need to talk next about how we can classify different types of materials based on the way that they respond to light. We're going to use these terms in the next couple of chapters. So next thing is in your notes, types of materials based on behavior with light. Depending on what a material does with light depends on how we will classify that material. Most materials, admittedly, that we would interact with on a regular basis are referred to as being opaque. Opaque. Opaque refers to materials which either reflect or absorb all light. Materials which either reflect or absorb all light. Materials which reflect or absorb all light. A typical mirror, when you look in the mirror, light is reflected off of the surface, right? Light strikes your face, reflects off the mirror back to your eyes, and you see what your face looks like. Maybe you scream, maybe you just do something about it, maybe you do both, okay? But the light is reflecting off. A mirror is typically opaque. Have you ever seen those mirrors, though, that you can see through the mirror to an extent? Okay, that is not what we're talking about. This tabletop, I cannot see through the tabletop. That's because all the light that hits it is either absorbed or reflected. Most of it, because it's a black surface, is absorbed. Just a little bit of light, very low light, is reflected off. Enough that I can see it, but it's absorbed. The dark blue hoodies absorb most of the light. Just a little bit of blue light is reflected off. My shirt is kind of a purpley, reddish, whatever color. Plum? I don't know. Burgundy? I don't know. And whatever color this is, right? Well, a little bit of red light, and I'm assuming a little bit of blue light is reflecting off of it. Most of the light is absorbed. The point is you can't see through it because light doesn't go through it this way, nor does the light from my arm go through it that way. It absorbs or reflects all light. The color that you see from an opaque surface is determined by the color of light that is reflected. The color that you see of a surface is the reflected light. So for instance, this chalkboard appears to be green because only green light reflects off of the chalkboard. The chalk appears to be white because all the colors of light are being reflected off of the chalk writing. If I were to take and break your chalk, if I were to make a strip of yellow on the chalkboard, we see red and green light being reflected off of this chalk. Hence, we see yellow. Does that make sense? So the bright blue over there on Zechariah's notebook thingy, well, it reflects what appears to be pretty close to cyan. That means both green and blue light are reflecting off of the cover. The orange highlighter right there. We see orange because there's a lot of red light and a little bit of green light being reflected off of the surface of the highlighter. As you look at the page, the colors you see are the colors of light that are reflected off. The other colors are absorbed. Does that make sense? So when you put printing on a page, the idea is the white paper reflects all colors of light. The black printing, where there's printing, it absorbs the colors of light so that we see black. Questions on what opaque means. Light is either reflected or absorbed. And that's a good thing, right? And in a lot of cases. There are other objects, though, that are transparent. Transparent objects transmit light through them. The word for allowing light to pass through is the word transmit. So transparent objects transmit light. Now, not always all light. Anyone ever looked in a car window, maybe your own car window, of course, looked in a car window to see a reflection, maybe make sure your hair's just right, or I do this to straighten my tie, so get out of the car, check real quick, okay, tie looks good. You can see through the window. Some light is reflected off, not all light goes through, but you can see what's on the other side because what's inside the car, the light from inside the car, does come through the window a little bit. Now, you can prevent how much light comes through the window to the outside by tinting the windows, right? That absorbs more of the light and stops it from getting through in either direction. It keeps it a little darker in the car so the bright sunlight doesn't hurt the eyes of young passengers. It also gives you a little bit of privacy as other people are driving down the road. Police officers aren't crazy about front windows being tinted, I'm told, because they like to be able to see what you're doing there when they pull you over. They want to be able to see if you're reaching for a gun so they don't get shot. But anyway, different states have different laws about tinting front windows, but rear windows, of course, can be tinted. So transparent objects allow light to go through, right? We see when the blinds are open, at least, we can see what's going on at the construction site across the way because light from the construction site passes through the window to our eyes. It transmits through that transparent surface. Other surfaces are translucent. Translucent surfaces, like transparent surfaces, allow light to come through. But as the light goes through the surface, the light is scattered, so that you can't actually see what's on the other side. You can see light coming through, but the light is scattered. Privacy glass, right? You go to some doctor's offices, and you can tell the light is on in there, so you can tell people are moving around. You may even see a little bit of shadow. Privacy glass in bathroom windows. Bathroom windows. How many at your house, window in the bathroom, and it's got there's some pattern to the glass so people can't see in? No window at all? Okay. The house I grew up in had this window on it that had this frosted glass type stuff. You couldn't see what was on the outside, you couldn't see it. That's good, that's what we want. The next house, our bathroom, as the kids, the main bathroom, master bath had glass, but our bathroom just had no windows at all. And then our current house that we moved to, it had regular glass. It was a little octagon of regular glass. Not crazy about regular glass window in bathroom for obvious reasons. How many ever seen, I know a lot of showers are bathtubs and showers. Ever seen a shower that's just a shower? Just a stand-up shower? It's got oftentimes a glass enclosure. Oftentimes frosted glass there as well, or some kind of textured glass. The idea is that although light can pass through, the light rays are scattered, so you can't really see what's there. That's translucent. So transparent, the light just transmits right through. Translucent, as the light passes through, it is scattered. Does that make sense? And then opaque, what does it do with all the light? Doesn't transmit it, it either reflects or absorbs everything so that no light passes through. Questions on types of materials. Now imagine though if we talked about tinted windows, imagine if I had a piece of glass that was tinted with color. For instance, a piece of red glass. Or maybe, do something maybe you did as a kid, a red balloon. Anyone ever, you did this when you were a kid, you had a great big red balloon, you smush it over your face, and everything's red. Hey mommy, you're red. Okay, how many did that as kids? My kids do that too when they have balloons. And the idea here is, because the balloon is red, only red light can pass through. Anything else gets blocked by the redness of the balloon. This is what we call a color filter. These are objects that are transparent but are tinted with some color. A filter allows only its own color to pass through. A color filter allows only its own color to pass through. It absorbs all other colors of light. And that's how a color filter works. It allows its own color to pass through, but it absorbs everything else. Well, okay, let's take Audrey, for instance. Audrey's skin is rather, not white, but it's not super tanned, okay? Her skin is going to reflect most colors of light, right? If white is all colors, her arms are reflecting most colors of light. But when I put the color filter up, the blue light and green light that comes through gets blocked by the red balloon. Only red light goes through, so that's why I see her arms and her face as red. Her face is also red now, but that's not because of, just kidding, it's not quite that bad. Look in your textbook, this is a computer-generated image, but they show, imagine putting a red filter over a red rose. They're on page 274. Well, as you can see the details of the red rose very nicely, can't you? But there's a lot that looks kind of black, correct? Now notice they take a cyan filter. Remember, cyan is a mixture of blue and green. So a cyan filter will allow both blue and green to come through. Do you notice when the cyan filter's there, you see the blues and the greens just fine? But notice what cyan won't let through, red. And notice the red part of the rose is now completely black. What does red only allow? Red, not blues or greens. So all the blues and greens came back as blacks and grays. That's the premise of a color filter. Again, it's computer generated, but I think it gives us the idea of how that would work. Questions on a color filter? I mentioned blacks and grays. Well, what is gray or grayscale? Gray isn't a color. Black is the absence of all light. White is all light. But imagine we get all the colors of light in lower quantity. A little bit of red, a little bit of blue, and a little bit of green. Well, we wouldn't see a nice bright white, we would see gray. Grayscale is this, low reflectance white. Low reflectance white. If you wanted to add this as well, all light is reflected but at a low level. All light is reflected off of gray When we see gray, we're seeing all the colors of light, but we're seeing them reflected at a very low level. So Audrey's shirt is a gray. Evie's shirt back there is a gray. Okay, they're reflecting all colors of light. The blue hoodies are reflecting blue. Their shirts are reflecting all the light, just at a very low level. So the darker the gray, the less light is reflected, until if you're wearing black, that reflects almost no light at all. Make sense? It's absorbing nearly all the light. By the way, if a black is absorbing nearly all the light, think about it, you go out on a hot day, radiation, energy from the sun's rays, right? It's already hot outside, but the black shirt absorbs all of that thermal energy then, all that radiation energy, and hence you get hot by conduction from the radiation to the shirt. Does that make sense? You wear the white shirt outside, it reflects all the colors of light. In fact, I remember as a kid, I grew up in Florida, super hot in the summertime, but I wanted to go play basketball at 1 in the afternoon for some reason. Dumb idea, I know. Well, we just pressure washed our driveway, and a freshly pressure washed driveway is usually a nearly bright white color. And so I step on the driveway, and as soon as I stepped out of the garage, bam, it felt so hot. Why? Because all the sun's rays coming down get what? Reflected right back up on me. So I'm getting rays from above and rays from below. I'm cooking from both sides. As soon as I stepped onto the road, it instantly felt cooler. Well, the road is blacktop. But you know what I discovered after about 2 minutes? My feet were burning up. Feet standing on black road, which has now absorbed the sun's rays, even though the rest of my body felt a little cooler in the road than on the driveway. It was a really weird moment because I could feel it. Like, you know, we talk about it in science class, but I could feel it that day and it stuck in my memory. So anyway, thought of that as I was sharing that. What about, for instance, Audrey has that green pencil there on her desk. Well, I see green because it reflects green light. Well, the chalkboard is also green. It also reflects green light. But her pencil is reflecting more green light than the chalkboard is. We call this brightness. Brightness. Think of neon colors. Why are neon colors so bright? Because they literally reflect more light rays. There are more light waves, if you will, reflecting off of them. So brightness refers to the amount of light waves reflecting off a surface. So we say something is a bright color. Well, it reflects more light waves. Trying to think of a picture, see an example in here. I don't know. I'll be boring and forget it. All right. Another thing would be this. This is kind of reddish. These darts, here, just kidding. These darts are actually more of a pure red, correct? This is reflecting red and maybe a little bit of blue as well. Not a lot of either one. This is reflecting a really good red color. The pureness of a color is called its hue. Hue is the pureness of a color. That which reflects pure blue, pure red, pure green, or even with the monochromatic colors, a pure orange versus orangish red. Hue refers to the pureness of a color, and without shading or tinting or changing the color in that way. Questions on the content from page 274. Just a variety of things there I kind of wanted to touch on and maybe make a little more sense than it did in the reading. Hopefully that helped. Questions? All right, we get now to pigments. Next thing in your notes, last thing in your notes for this chapter, subtractive primary pigments. Subtractive primary pigments. You say subtractive. Well, what does subtractive sound like? Subtracting, taking away, right? What does a pigment do? When you take that crayon or paint or printer ink and you put it on a page, this page used to be pure white at one point. It would have reflected all the light, but as soon as you put that red box, that area now only reflects red. You've absorbed everything else. The cyan, now only cyan gets, or cyan, which means greens and blues, get reflected. It absorbs everything else. Your definition for pigments, these absorb colors of light, allowing only certain colors to reflect. Pigments absorb colors of light, allowing only certain colors to reflect. Pigments absorb colors of light, allowing only certain colors to reflect. It's basically like the color filter. The filter only allows its own color to go through. Well, a pigment, when you put it on the page, only allows that color of light to reflect off now. You're subtracting all the other colors. So you take a white t-shirt, it reflects all the light. Now you take a red t-shirt, it has a red pigment in it. Now only red light gets to reflect off. Everything else gets absorbed. Does that make sense? So that's the idea of a pigment. There are three primary pigments: cyan, yellow, and magenta. And you might be thinking, wait a second here. Right, these are the secondary colors of light. Interestingly, you cannot make cyan as a pigment by mixing anything else. It is its own pigment. Same with yellow, same with magenta. You can mix light to make these colors, but these pigments cannot be made by mixing anything else. But when you mix them, you can make all the other colors. You ever looked inside a printer, or maybe had to change the ink or toner in a color printer, and you notice it's a tricolor cartridge, or 3 individual cartridges, cyan, yellow, and magenta, because the printer will use these 3 pigments in different ratio amounts to make literally any color you want. Now, if you mix 2 of them in equal proportion, cyan, for instance, and yellow, well, now we're talking like we would in art class. Blue and yellow make green. So cyan and yellow collectively make green. Yellow and magenta, pinky and yellow. Well, the yellow takes out the pinky element and makes it a nice true red. And cyan and magenta make a perfect blue. So that the subtractive secondary pigments are red, blue, and green. The subtractive secondary pigments are red, blue, and green. You literally just reverse them. The primary colors of light are the secondary pigments. The secondary colors of light are the primary pigments, and that makes them easy to remember. So the subtractive primary pigments, cyan, yellow, magenta. The subtractive secondary pigments, blue, green, and red. What if you mixed all the pigments? Well, remember, what does a pigment do? Absorbs all the light except for itself. So if you put all the pigments together, it should absorb all the light, and it should make black, in theory. You know, because you did what I did, and you scribbled all the crayons, you know it didn't come out to a perfect black though, right? It really came out to kind of a nasty brownish color, but in theory it should be black. Have you ever had to print black and you didn't have a black cartridge in your printer? And so the printer used the color cartridge to make black? It wasn't quite a perfect black. It should have been in theory, and not quite in reality. But black would be theoretically the result of mixing all 3 subtractive primary pigments. Questions on pigments? All right, one last thing I want to do, and this is something I discovered years ago. Back in the old days, we used what are called overhead projectors. You know what an overhead projector looked like? It had a clear tabletop, if you will. Light would shine up through it, reflect off a mirror, and a lens that would flip the image. We'll talk about that when we get to the refraction of light, reflection of light. But anyway, and it would project the image onto a screen. So I used transparency markers, interesting, blue, green, red, and black, subtractive secondary pigments in a mixture of all 3, on my transparencies an awful lot. And of course I'd have to rinse them off and clean them off from time to time. And I noticed something interesting one day when I was cleaning my transparencies. Again, this is last decade, maybe a couple decades ago. And so I want to show this to you. Camera, I'm going to try to show this to. But if I wanted to erase the whole transparency, I would just rinse it off in the sink and then dry it off with a towel. But if I wanted to just erase a small portion of the transparency, I'd take a tissue or something, and I'd wet the tissue just a little bit, and I would erase, just for instance, the green. Or maybe I would take a little bit of tissue and I would erase just the black. Or perhaps the blue. And what I discovered is that the water molecules caused the individual pigments to separate. So you can actually see in these secondary pigments the primary pigments. So we're going to see if the camera will be able to see them. I think you all will in just a moment. All right, Michael, you can go ahead and come on up here. The green is the fastest. If you look at the green, looking around the edges of the green, do you see both cyan and yellow separating out from the green? See the yellow around there, you can see the cyan around the fringes as well. The black is interesting because I think you can see the cyan, you can see the magenta, and down there you can see the yellowish hint as well. It'll get better as time goes on. The red is the hard because the red is almost a magenta itself. You can see the pure magenta separating. It's harder to see the yellow on this one, but theoretically yellow magenta would make red. And here you should be able to see that the cyan's really prominent. It may take a little bit longer for the pink or the magenta to show up along the edge, but it will eventually come out. Again, these two are the easiest to see. So Kendall, they're looking for cyan and yellow. Audrey, you see the cyan and the magenta and a little bit of the yellow maybe in there as well. Trade with these. Again, I'm waiting for the magenta to show up. Study hall, you're dismissed. Waiting for the magenta to show up here on this one. And again, in time it will. I think what I'll do is I'll take these back to my classroom and I'll just let them sit for a little while and allow the colors to finish separating. I'll take a picture, I'll upload the picture for the YouTube viewers to see, but just really fascinating. And it struck me one day what was happening. I just happened to glance at the tissue as I was erasing, like, whoa, those are the primary pigments. So kind of neat, wanted to share that with you. All right, there is no homework this evening or over the weekend, I should say. You have a quiz coming up Monday, so be studying over the weekend. We'll review again Monday before we take the quiz. But quiz Monday over chapter 18. We'll do a little bit of review also on Monday for your test coming up Wednesday. That's lesson 127. I said 126 yesterday. Lesson 127. Lesson 126 will be all test review. All right, you are dismissed.